Hello everyone and welcome back. In a recent video, I went over how to get started working with Python. We covered how to run a Python file, how to use comments, how to use variables, how to use operators. And now, as the next video in this Intro to Python sequence, I want to cover what's called I/O. So I'm going to make a new category of comments and codes in this main.py file we've been working in called I/O, or input output. Let's start with output. Output is the goal or the action of trying to write something to some form of output, something outside of our program. And what we've been writing to has been our console or our terminal output. We've been doing this using print. So for example, line 59, we print 5 mod 2. 2 goes into 5 evenly 2 times with remainder 1. So our output from line 59 went to our terminal console and it displayed the character 1. So let's expand our knowledge of working with print to include customizing our print statements and then also how we can format floating point numbers, such as rounding them to 2 decimal places, because this is a common action that you'll want to do. All right, so let's start with some more on print. You can see on my screen here a little overlay showing a preview of the documentation for print. So you can see that print accepts values that are written to a stream or to sys.standardout by default. So sys.standardout is our console output, and that's why we're seeing everything we pass into this print function going to our terminal output. There are also optional keyword arguments: file, sep, end, and flush. All right, so let's start by seeing how we can pass multiple values to print and how those are printed, and then we'll start looking at this sep, which is short for separator, a string inserted between values. By default, it's a space. All right, so let's say I'm going to print out A, B, C. So I can pass in multiple values to the print statement. We don't have to pass in just one value, such as the result of 5 mod 2. So by default, we're getting a space inserted between each value that we're separating by a comma as we pass them in as arguments to this print function. So according to the documentation, that's because sep, which, like I said, is short for separator, is a string inserted between values, which is default a space. Okay, well, what if I don't want to have a space in between my arguments to print when it is printed to standard output? So I'm going to add to the end of my print statement another comma for another argument to print, and this one's going to be a keyword argument, which means I have to put the name of the argument, which is sep, and then an assignment operator, and then the string value I want assigned to be sep. So I'm going to run this again, and now there are no spaces in between A, B, C. So let's keep our original print statement so we can compare it. So here, by default, A space B space C, and then overriding that default space behavior going in between each one of these arguments we're passing to print to be the empty string, which is no space. They're all jammed right next to each other. Let's do one more demo of sep. Let's say I put in 3 stars. Now there will be 3 stars separating our arguments to print. And remember, we can put in as many arguments as we want. I could do 1, 2, 3, x. X is a variable we were declaring earlier, and then maybe z. So these will all be separated by whatever string I say they should be separated by. All right, let's do another demo. This time, let's take a look at the end keyword. By default, the end keyword is a new line. So let's take a look at the documentation. It says end is the string appended after the last value. Default, a new line. That's why every time we have a print statement like line 51, 53, 55, 57, 59, 62 through 65, they're all showing up on their own lines in our terminal output. But let's say I don't want them to show up on their own lines. I want, say, multiple line output to span multiple print statements. So let's try this. So I've got two print statements. This first one on line 65 overrides the default newline character to be the empty string. So pretty much saying, hey, print, don't append any character to the end of my values. So here's the output from line 65. Since there's no newline at the end of line 65's output, line 66 output, XYZ, is just jammed right on the end. Now, I didn't override the end behavior for line 66 print, so there is a newline character appended to the end of X space Y space Z, just like default. All right, now let's talk about how we can format decimal numbers, say by rounding them to 2 decimal places. Let's use math.py. I imported the math module in a previous video up here, import math. If I print out math.py, I'm going to see 3.14159 and a lot of digits. So this is a great floating point number to work with because it has so many digits, and in many cases, I don't want this many digits to display. So let's see how we can round pi to 2 decimal places. And there are actually a few ways to do this. Let's start with the Pythonic way. And the word Pythonic just means like the Python approach or how to do this in Python style. So we'll have a print statement where we'll have a string and we'll call .format on the string. And we'll pass in to this function, or AKA method, some arguments that should be inserted into our string. So that means we need placeholders for where these strings should go. So in my string, I'm going to have a set of curly brackets, and this will be a placeholder for a value to be inserted into. So the value I want to insert is math.py. So math.py is going to go right in here. And now I'm going to provide some additional information to format about how I want this floating point number to be formatted as a string. So I'll have a colon and then 0.2. So the 0.2 is going to specify 2 decimal places to the right of the point. And then F saying this is going to be a placeholder for a floating point number. Now I run this and I get 3.14. Let's see another way to do this. This is an old school C style way of doing it, but you'll see it around a lot, so let me show you. Very similar to what we were doing with placeholders, but this time instead of curly brackets, we're going to use a % sign for a placeholder, and then 0.2f, and then instead of .format, we will have % open paren, close paren, and in here, we'll put our list of values to be inserted in our placeholders in our format string. Now we're only going to have one placeholder, so we'll only have one value to be inserted, which will be math.py. And the last way I'll show you is to use the built-in round function. The built-in round function actually does round the floating point number and essentially create a new floating point number for which you could print it or assign it to a variable or write it to a file. This is unlike the previous two approaches, which don't actually round the number and produce a new number. These previous approaches produce a string. So let's print round math.py. If I don't pass in a second argument, this is going to round a floating point number to the nearest integer. But if I want to round this to say 2 decimal places, then I'll pass in a second argument to round, and now I'll get 3.14, just like my other two approaches. Now, round is a built-in function. We've actually seen a few other built-in functions so far. Print, for example, is a built-in function, and type is also a built-in function. Now, I'll mention that POW is not a built-in function. We needed to import the math module in order to use it. Pi is not a function because we didn't have an open paren, close paren in order to invoke it. It's not code, so to speak. It's a variable, it's a value. So we did need to import the math module to access this variable, pi. And you can see here, it's a floating point number. So this has been some more details on the O of I/O output. Now let's do some examples of the I input. So let's have a section here on getting input from the user. Right now, our program is very one-sided. Our program can generate output for the user to view or consume or look at, but we have no way of getting any data from the user, right? So we want to kind of make a bidirectional interactive program. We can display something to the user, we can get something from the user, we can do something with that, display something else to the user. Let's see how we can do that in Python. So let's say we want to get the user's favorite number. The first thing we should do is put what's called a prompt in our code where we tell the user what we want from them. So we can use a simple print statement for this. So I'll say something like, please enter your favorite number. So when this runs, the user will see this, please enter your favorite number. Now what we want to happen is essentially a cursor kind of blinking at the keyboard, waiting for the user to enter in a value. So in order to get a value, we'll use the built-in function input. You can see the documentation here says, read a string from standard input. The trailing new line is stripped. Okay, what does that mean? Well, let's try and run it. So it looks like our program waits on line 80 for some input from the user, from standard in, which is tied to the keyboard. Okay, so let's say the user's favorite number is 5. So they type 5 to denote that they're done typing, they're done entering their answer, they press enter on the keyboard. So enter is essentially tied to the new line character, which is inserted at the end of the string, so 5 new line character, but input, as the documentation stated, is going to strip that out for us. So we'll just get 5. So right now on line 80, we're not doing anything with the 5 that is returned by input. So let's store it in a variable called favorite number. So now I'm going to print out back to the user, your favorite number is, just to confirm that I can in fact get and store their favorite number. So I run this, I say my favorite number is 5, and then it echoes back out, your favorite number is 5. So far, so good. But let's see what happens when we say, try to do some arithmetic with favorite number. We want to do something with it. So let's do your favorite number doubled is, and then I will do 2 times favorite number. So if I enter in 5 as my favorite number, 2 times 5 is 10. I should see your favorite number doubled is 10. So I run this and I say 5 is my favorite number, but it actually says my favorite number doubled is 55. So this is really strange, right? Let me explain what's happening. Input is going to return a string. In a future video, we'll talk about definitions for functions in Python and how you can call a function, all sorts of fun functiony things. But for now, looking at this documentation, it tells us that input is a function and that this function returns a str, a string. That's what this arrow here means. Arrow, str. So that means that this function is going to return a string. I'm trying to multiply a string by 2, which is having the effect of just repeating that string twice. So this is kind of fun. When one of the operands of the multiplication operator is a string, we don't get the standard arithmetic multiplication that we're used to. We get what's called string repetition. It becomes the string repetition operator. Let me show you a little demo of this. Let's say I do 3 times hello. This is going to give me hello 3 times. Kind of interesting, kind of fun. So how can I confirm this suspicion that I'm getting the string repetition operator here and I'm getting the character 5, Well, let's print out the type of favorite number. And it does indeed show us that the type of favorite number is string. Okay, well, if I truly do want to do multiplication, right, I want to do arithmetic with favorite number, I'm going to have to convert it to a numeric type, such as an int or a double, so that I can get 2 times 5 is 10, not 2 times 5, the character string, is 55, 5 the character string. All right, so let's take a little bit of notes right here. Let's say we really do want favorite number to be a numeric type, for example, a float or an int. So what we'll need to do is something called type conversion, where we convert a value from one type to another. For example, we want to convert a string into an int. Thankfully, this is pretty straightforward to do in Python because there's built-in functions that can help us do the conversion. For example, if I want to convert the value in favorite number to an int, I can just use the built-in function int. You can see here it says convert a number or string to an integer. Awesome. So let's pass in favorite number. This should return an integer. So I'll store this integer in a variable called favorite number int. I will print out favorite number int. And I will also print out favorite number int's type. So I'll enter in 5. So now you can see on line 89, we print out favorite number int. It's a 5. It looks just like it did before, but now the type is an int, not a string. So let's try multiplying 2 times favorite number again, but this time we'll do favorite number int. And now we get the output we originally expected, which is 2 times 5, the integer, is 10, the integer. So to recap, in this video, we dove in a little bit more into how we can use print in order to write text and formatted decimal numbers to output, which is our console. We also learned about input, how we can get input from the user using the built-in function input. Along the way, we got to learn about type conversion, which is really, really, really important. Now, this example worked really well because the user entered in 5, which can be converted from the string 5, storing the character 5, to an integer. But what if the user entered in something like hello? So let's say my favorite number is hello. Oh no, we get some kind of garbage output here. It says traceback, most recent call last, main.py line 88. This is line 88. It says value error, invalid literal for int with base 10 hello. Essentially, int is throwing what's called an error, an exception, saying that hello cannot be converted to an int. So we're living in what's called happy user input land right now, where We assume that all of the input we're going to get from the user is good, and therefore our code is happy. But as you start to learn more about Python, specifically what are called exceptions, you'll see that you can write robust code that can handle cases like this where you don't actually get good input from the user. So stay tuned for a future video to learn about exceptions and handling them in Python. But for now, you can assume that the input you're going to get from the user is the type you want until you learn more and can write robust code to handle those kinds of cases. Thanks for watching, and please subscribe to my channel and check out some future Python videos.